This video is about an exercise in decomposition and abstraction. Probably the most important thing that we've talked about so far, probably the thing that's going to make you a better programmer. What you're trying to do in decomposition, and I'll sort of explain it here, I got it written up here in a second, but you're trying to basically break down the problem. In abstraction, you're using those things that you broke down in order to bring it back up and actually use the things, your creations, in order to solve it. So the exercise that we're going to use is not a hard one. So don't think that this is the only way to solve this particular one, but it's one that you can use. I think anyway, the example is one that's hard enough. If you try to do it without functions, it's not going to be super easy, but it's not terribly difficult either. So just know that going in. And then the next part is I just want you to note that it's probably not the least amount of code. Like, I'm not trying to efficiently write code here. What I'm trying to do is think about how to take a problem, break it down into sort of subcomponents, and then solve those subcomponents, and then bring it back up to solve the actual problem. So that's the idea of decomposition, and then using abstraction to get back to the actual problem. So suppose we want to do a multiplication table. So I want a multiplication table that looks like this one. It doesn't have to. So I'm not tied to 7. I want it to be able to do anything. If I put 10 there, I want it to go out to 10 over here and to 100 as far as the multiplication table. But I want it to print to the screen. So I want to print something to the screen. So in the idea of decomposition is taking this problem that may seem like it's difficult and saying, okay, well, I know I need to figure out the sub problems, the things that you need to be able to do in order to solve that problem. So that's the idea of it. And is there something that I can do in order to solve, in order to make this, to make the overall problem easier on myself? And what I did was I said, well, give some number x. So example, if x is equal to 1, then I'm going to produce a list. So 1, 2, 3, 4, or 2, 4, 6, 8. If my number is x equal to 2, I want to produce all the multiples of that number. So for example, here 3, I can do 3, 6, 9, 12, and it's just going to be in a list. So that's my subproblem 1, and I believe we've already solved that one in video 1, but I will bring that back up here in a second. And I've changed a little bit of it because I think I've left out the 0. I think in the previous one we had a 0. I'm not going to start at 0 because there's zeros in all of them, so it just makes the table not look as nice. Okay, so if I had this list, right, so my next thing that I want to solve, the next subproblem, if you will, is given a list, can I print them to the screen? Okay, so can we print these things to the screen? So once you have this thing and we've programmed it in, I can put in 1 and get all the numbers from 1 to whatever my maximum number is going to be. I can put in 2 and get all the multiples from starting at 2 all the way to whatever my, in this case, 14, 3 to 21, 4 to 28, and so on and so forth. But once I have those lists, then I have to pass them into this second thing here that will just print that one line to the screen, and then the next line to the screen, and then the next line to the screen, and then format it in a way so that it looks nice. And then once I have these two things, well, then I can just do a little for loop that takes 1, 2, 3, and so on and so forth, and just prints them off to the screen one at a time. So that's the idea. That's what we're going to do. So let's go ahead and bring up Anaconda. And what I did was I just added the function that we already created back in, and I think this one is the one that had the doc string in it. But this will given, let's go ahead and run the code. So it does what we expect it to do. The only difference is I put a 1 here in the range instead of just letting it go to num plus 1, because that would have been a 0 to start off with. So I wanted to start at 1 instead of 0. And then we printed it off, so you can print it to the screen. I set it equal to A here because we're going to use this to validate or verify our next function that we're going to make. So step 2 is that idea of printing the list. So given a list, so def, I think I call it print list, and L, you can, whatever you want to put in here. Remember the variables, this is a local variable, so it's going to be destroyed once print list goes away. And then I'm going to put a space. I'm going to let the user choose how big of a space, like, so for example, if you chose a multiplication table that had hundreds in it, well, 100 times 100 is bigger than my little space of 3. So in other words, I'm going to let the user sort of move around the space, and I don't know if I've talked about that yet, but we will get to it in a second, or how to use a variable in your format spec. So that's what we're talking about right now. All right, so I'm going to start off with the result. So again, I like to use RES as sort of the result that's going to come out of this thing. And then I'll just loop over. I'm going to loop over my list. So for L in capital L. So I always use a lowercase here, and then over the, so if this is my uppercase thing, or if this were a word entry, I would probably use E. If it was whatever sort of goes there, that's sort of the language that I use. And then in here, I'm going to say result is plus equals, and I'm going to throw an F string in there. And what is the F string going to do? Well, it's going to have, probably shouldn't have used L. Let me change this back. Let me say element. So element in list. Element, and then the only reason I don't like the L is because it looks like a 1. I'm not real happy. I wasn't real happy with that. So this will be the SP. So this is how, so come over here. Using a brace is how you tell it that I'm using a variable, so that it knows it's a variable in here. And then using a brace inside the format spec. Remember, the right-hand side of the colon is the format specification. So using a brace inside there tells this thing that there's a variable associated with SP, so it knows to go out there and grab SP. And then, so that's all we're going to pass, and then we can print. Yes. Probably wanted to print. Yeah, so that's probably all we needed to do. F9. And then let's just view print list and then throw an A. Make sure that it does. So it's doing what we suspect. What if I put in SP equals 5? Did it make it bigger? And it did. Okay. So it's doing what we think it should do. And now let's just put these two things together. All right. So so if I put in, let's just make sure, if I put in 4, and then my num's equal to 9, and I come back over here and I redo this, I get 4. If I put in 5 here and I come down here and rerun this, I get 5s. So it's doing what we suspect it should do. So therefore we can just put it all together and say for I in, let's see, we want to go range 1 to 10 in this case. MR, so multiplication row. I'm just letting this, we can just let it be row. Row is equal to mult row I. I guess I'm gonna change it. So they're gonna let row equal that, and then print. All I need to do is print after I've done that. And then do we need to change our spacing? I don't know. We'll see here in a second. So what I've done now is put all that information, all that stuff together. So I'm going to let 1 go in here. It's going to produce this list from 1, 2, 3, 4, all the multiples of 1. Then it'll go in and put 2 in, put all the multiples of 2, and so on and so forth. So let's see what happens. All right. So we get this real tight multiplication table. Do you see, hopefully, that I've abstracted the fact that I know what this thing's doing? I don't need to think about all the details on what mult row does anymore. If I pass it in a number, and I don't specify what num is, then it's going to do exactly what I want it to do. And I've also abstracted what print list is going to do, and that's why I'm able to produce this little chart here. Let's make it even better. So I'm going to say make it even better. How am I going to make it even better? Hopefully you're sort of thinking about this already in your head. What if I just wanted a multiplication table? So def multiplication table function, and I can pass it in the numbers, right? Because I want to go, in this case, I just went from 1 to 9 and 1 to 9, but I'll let numbers change, and we can also let the spaces change, and we'll let it be 3 unless you say something different. And then all I'm going to do now is simply do the same thing that I did in here, except I'm now generalizing the stuff. So I'm not going to go to 1 to 10. I'm going to go to from 1 to n plus 1. And I'm going to put a little bit more niceties, nicety thing kind of things in, right? So I'm going to let it first print a couple blank spaces, right, to get away from all of the clutter so that I can basically make sure that that you're not seeing like some of this other garbage stuff up here. I'm only seeing the multiplication table, and then I'm going to let this TBL be a table, and I'm going to pass that out just in case I want to use it later on. I'm going to return this information from my multiplication table. So in other words, it's going to be a list of lists that has all of the data that's in the table. So it's going to have, so that would be the first list, that would be the second list, that would be the third list, and so on and so forth. So for I in range, I'm going to go from 1 to num plus 1. So I'm going to do that little guy. I'm going to say the same thing, Mr. No, I'll let row equal multiply row I comma num. Remember, num is what it's made to 9, but we can change it. So if you don't change it, it'll just be 9 again. And then TB, at this point, I'm going to just append in this row. So because I know that's I could append in the string if I wanted to, but I don't want to do the string. I'd rather have the list in there so I could mess around with it if I wanted to as far as data goes. And then I'm going to print list mr row comma sp equals sp. So again, this is a local variable. In this case, it would be equal to 3 unless it gets changed, and that's what's on the right hand side. And the left hand side is what this function here calls sp. So this is going to pass into this function, whatever that sucker is. So don't be confused about that. And then I'm going to just return table. Okay. So now I'm going to call it multiplication underscore table is equal to mult table. Let's see, we'll go 9, we'll do 12 comma, and we'll have 3, and we'll see what that looks like. So I gotta highlight all of these, run it, and it's a little close in there, right? So you can simply go in here and say, no, I want 4, and you can see what happens. All right, that's all I got for this class. I will see you guys next time.